Yes, I can hear you because I'm listening to you on Discord, right? So that we don't have delay between each other because that would be bad. So okay, yeah, that's what I was
I
going to say.
think it has been fixed now.
Curless.
Yes, it does appear to be. It does appear to be fixed now. All right. Yes.
Well, we
Um,
had better start over then, Raf,
yes.
because
I had better start over because obviously nobody could hear a single thing I was saying. Thank you for letting me know, Carolus. I really appreciate that because I had absolutely no idea. Okay, so here's what I was actually attempting to say here. Um, there's basically two. Well, all right. We start at the very beginning. The first thing that we were going to tackle today is the question of basically having these components be mirrorable. One of the things I really, really, really don't want is the idea that you've got a component and it's and you need like a separate one for the right and left side. I mean, obviously this is not good. We want to be able to author the component once and use it on either side interchangeably. But this does bring up a couple of questions about how we want to handle mirroring in this system, right? And I was saying that one thing that is often a good idea, but I don't think I'm going to do it here, and I wanted to explain why, is putting components or chunks of rigging in other contexts um, under a scaled space, essentially shifting it from a right-handed to a left-handed coordinate system. That's sort of what that ends up meaning, right? So, that's actually what we chose to do for all rigs for the Senate Machine 3. And it is actually a really nice thing to be doing because you get to have this full. You don't need to do any sort of more complex adjustment of the rig to allow it to be essentially inside out, which is what we're going to have to do here. To allow it to have controls, for instance, pointing along negative x instead of x. Instead, everything points on x. It's just that x now means something different, and this is very, very nice. However, I think that that is not what I want to do here, and the reason why I don't want to do it is that it becomes a little bit complicated when you want it to talk to other aspects of a rig, right? And one of the things that we really want here is the idea that the user who's created a rig using this componentized system can build more stuff on top of the rig and can do so without really having to rebuild anything. I mean, that's an important feature. No rebuilding is necessary. Um, but also that it's pretty straightforward to do so. And undoing that mirroring so that you can constrain something properly, for instance, can be a bit of a minefield. I mean, it's not a really big deal if you know how to do it and you know that that's something that you need to be aware of. But many users may not. And so I generally don't want to I don't want to take anyone by surprise by the consequences of putting whole rig components in a mirrored space. So the alternative is to do sort of the more traditional thing, which is you've got your chains or however you want to put it pointing down x on the left side, and they're pointing down negative x on the right side, and everything's sort of flipped around, and all values have to accordingly be inverted. And that is a little bit more complex because you then have to actually consider that. Now, it is a lot easier with Contour, though, than it is with in sort of the general case, where you have more stuff that you have to handle. Contour is pretty good at this. Nevertheless, it's going to introduce some additional complexity, but not, I think, an unreasonable amount. It does have one consequence that, again, I'm not super happy about, which is that translation is not automatically mirrored in this context. So you have rotation is, right? This is sort of the classic thing that you see in rigs all the time. You've got FK arms or something, the same rotation values will apply on both sides. So you can pose them both at the same time, and it makes it easy to copy values over. They will not be for translation. Also, not uncommon. People are kind of used to it, so it's not the end of the world. But I really do like it when you can have translation values essentially be the same thing on both sides. It makes things very nice and clean. But it has these other consequences that we kind of don't want to deal with. So, in order to make the rig invertible, I'm going to start with the finger because it's, a pretty simple case, and then we'll do it to the arm. And the first thing we need to do is to have a way of knowing what side is this, right? And there's a couple of ways that we could do this. And one way that I've used in the past is actually that I actually look at the values of the guides in order to know if, and sort of extract the information of if something is left or right. I.e., are the guides on the left side? If so, that must be X. And if they're on the right side, it must be negative X. And this does have the advantage of you can't get those things out of alignment, as it were. Like, you can't confuse them. It's just, it is what it is. But it also means that things get much more complicated if you, for some reason, have a component that crosses that center line. Now, in this case, you probably don't have a finger that's at 0, 0, 0 under most circumstances. So you could say, and I have done this in some cases in the past, well, this doesn't really matter. But I think that for a more general purpose thing, for something where I'm trying to create something that doesn't have any gotchas in it that are going to confuse people, having it be explicit maybe makes more sense. So that requires another input, and an input of a slightly different type. And what that input is going to be is it's going to be essentially a switch. Like, is this the left or the right side? So all of the other inputs that we have here, these are all matrices. You could argue, actually, that what I have here is not really the same kind of input. But it sort of conceptually is, because the idea with the components is everything about their internal behavior should only depend on their inputs, right? They shouldn't have any other information feeding into them to tell them what to do. So even though this is sort of a different kind of input than these world matrix inputs that sort of define everything else, I still think it's sort of in the same category, and we're going to add it to the inputs node. And what I'm going to do there, I think, is I could just make a bool that says, left or something. But what I'm actually going to do is make an enum, because I think it's a little bit easier to think about, basically, even though practically speaking, it's going to end up being the same thing, right? So let's call 1 left, or actually that the value of 0 becomes left, and right becomes 1 becomes right. Oh, yes. Also, I have to name the attribute. That helps. All right. So if this is on the left side, and here's where doing things with contour can make things a lot easier, right? On the left side, all of these bones, which I am not currently looking at because I'm probably hiding bones. Yeah. All of these bones are pointing down the x-axis. And when we flip this around, they'll all be pointing down the negative x-axis. So here's how you would do this. And once again, I'm not going to script this, as I might do otherwise, because I am trying to create... Oh, I just did something. Yeah, there we go. I accidentally unparented something. Because I am trying to create a situation where what I'm doing is a little more visually clear. Although I probably will rely on some scripting when I get to the space switching, because that's just so painful to do without it that I may just have to do that, right? And I'm going to put down a conditional. And I'm going to bring in the inputs. The first term, if the first term equals 0. Now, let's take a look at this enum that the bones have. What do we have here? So that's 0 or 3. Those are our two options. And let's grab all of these bones. Come on. Bone axis. There we go. Maya thinks you shouldn't connect it because it's not keyable, but you can actually. I don't feel like searching through that list again. let's see, side bone axis. Oh, right. No, sorry. That's I'm doing that from the conditional, not the inputs node, of course. Stop that.
Yeah, it might be worth like narrating a little bit what you're doing here in the command line, because the thing about it is I know a lot of people are a little bit scared of Python scripting,
Sure.
right? If they come from a background of doing traditional rigging, but there's some stuff that's pretty easy to do in PyML that I think is absolutely worth learning to do if you're going to rig, right? I mean, you don't have to become a full-on dedicated programmer to be able to do some very
Sure.
useful
Yeah,
stuff.
no, very much so. So let me just make it clear what it is I'm doing here. So I'm using the selected function. PA is what I'm calling PyML, specifically PyML.core, which is actually a little non-standard. Usually people call it PM, but whatever. Selected is the function that gets the selection list, like all the items you have selected. And I have 2 items selected, right? So then I slice it, which is a Python feature, this thing where I have the 0 next to it, that says get me the first item in this list, because 0 means 1, which is actually a good thing. I know that seems weird if you haven't done much programming. It's actually a good thing. And 1 means 2, so I'm saying the first item in the list, i.e. my condition, I'm taking its attribute second term, and I am plugging it into the attribute bone axis of the second item in my selection. And now I can just keep doing this, which is why I like doing things that way, because often doing it in the UI is actually kind of obnoxious. So, if I go to the inputs and I change the side to right, you won't see any apparent difference to begin with. Actually, that didn't change at all. 1 second. I probably screwed something up here. Oh, because I'm an idiot is why I plugged the second term in, which is always going to be incorrect. The second term is always 0, therefore everything appeared correct. What I actually needed to do was color if was output color, and output color R specifically. Sorry, that was a random mistake. Also, that's not actually, it's not output color, it's out color. There we go. So what just happened there, in case it was confusing, which it may well be, right, is that for reasons that I honestly cannot explain, my brain did a random thing and decided that second term was actually the output, right, of the condition, which of course it is not. What it is actually, because conditions were originally meant as shading nodes, is that out color is the output of the condition, and there are of course RGB values in there, but I'm only using one of them. And you can see that when you look at the condition and see that what I have actually put in here in the color if true R and the color if false R are the 2 values that I want. And again, to sort of explain this a little bit, you can see this one has in fact taken on negative x-axis. To explain a little bit, and in fact it may have inverted now. Yes, actually it did. That what I'm doing here, what this actually is an enum, meaning each one of these values, each one of these names that have been given to each value actually represents a number, and they start with 0. So that's 0, 1, 2, 3. So if I want it to be the x-axis, that's actually 0. If I want it to be the negative x-axis, that's actually 3. So that's why I'm doing this. I just did a completely random thing, as my brain sometimes does, and plugged in the wrong thing.
Does Maya really have no sort of conditional switch node that can actually output enums? Is that true? That's kind of unfortunate, actually.
Yeah, nice well, Maya doesn't have, as say Unreal does, for instance, some really nice sort of programming language-y, right, sort of data types and the sort of the enforcement of particular sorts of data types. I mean, similarly, like I'm pretty sure.
It does have enum,
yeah.
right? Like that bone axis actually is an enum attribute. I know because I wrote it.
Oh yes, the bone axis is an enum attribute, but the value that I'm plugging into it is actually a float.
Sure, but what I'm saying is it'd be kind of nice if there were a way to do a conditional that actually output the enum that would allow these things. It's kind of too
Yes,
bad.
it
If
would.
that
Yes, it
really
would.
doesn't exist, it's kind of too bad that doesn't. But
It really doesn't. Yeah.
we probably shouldn't get too off track here. But
Right.
this is bothering my sensibilities a little
I
bit.
mean, I can understand why. I'm not super pleased with it myself, but and there are other alternative ways of doing this, but they tend to be worse. Actually, I think. I mean, among other things, one of the ways to do a conditional like this would actually be a driven key, and that is not actually better in my view. Not that there's anything like necessarily wrong with using driven keys in general, or that there's any performance issues with using them. Actually, they're pretty fast as I understand it. But you know, I think that is even more muddled in terms of its actual behavior, right? So yes, as Matthias Rovik says, Maya bothers a lot of people's sensibilities. Yes, I'm sorry to say that it actually does. And I am not particularly pleased with this way of doing things, but it is the most sort of direct way of doing it that I'm aware of. So this is what we're doing. Anyway, what this now means, and you can now see that everything has been flipped over to the other side. What this, but you know, we are going to have to modify the results, right? In a way that will be fairly obvious in a moment. What this actually means is that the moment that I go and I change this value on the input from right to left, I am changing what direction the thing's pointing, right? I'm just changing all of these bones to say that they should point down the negative x-axis. Now here, again, is a way in which I really appreciate this way of doing things over sort of Maya's approach to joints, where they're all transform nodes, and they have some things baked into them, like joint orient, but then their translation is just translation. There's no concept of, well, here's the length of a bone. In one of the ways in which Contour makes this sort of thing more explicit is that the bone has both a length and a direction of length, right? And x-axis and negative x-axis are not your only options, right? You potentially could have, I mean, I'm not using them in this particular system, but you can have to point down any axis, right? That makes what the bone is and what it means a lot more explicit, and I like that. There are cases where it makes sense for something to be totally freeform, and Contour lets you do that too. I mean, you can unparent the joint from the bone if you want to. It's not a requirement. But it is, I think, very nice to have that structure in place. But obviously what that means is now we've got the guides way over here, and, you know, they're doing what they should do, more or less. Well, they aren't really, right? Because it's actually mirroring over the values in a... when you take those same rotation values and you mirror them over to the other side, they don't mean the same thing, right? So there's a little bit of additional work we have to do to change how the guides control this stuff based off of whether it's left or right? And one of the first things we need to do is to actually flip these over to the other side so we can see things a little more clearly. Now, right now, in order to do that, though, if I went and put this on the other side, I'm actually like truly mirroring things over in a way that we don't want, right? That doesn't make any sense for this.
I have a question for you,
yes.
Rap. Yep. It's kind of a dumb question, and I don't know. Maybe I shouldn't even be interrupting this process. I kind of want to ask it. I'm having a little bit of a hard time doing this math in my head, or doing sort of this geometric intuition in my head. Mm-hmm. If you were, instead of doing what you're doing here, if you were using a negatively scaled space, would it still flip these, or would it not? I'm trying to like work that out.
Well, if you were using a negatively scaled space, what you would probably do is take both the guides and the component and put them under it, and then everything would just work. Like all values would be the same.
That's kind of what I was thinking, but I was a little unsure of.
Yeah, no, that is how this would work. This is what I'm talking about the idea that, like, yeah, negatively scaled spaces are really nice. They avoid a lot of extra work. It kind of sucks that we kind of have to do all of this extra stuff to make this work properly. But
there's good
kind of stuck with it, right? You know.
Oh, yeah, sure. I was just curious.
Yep.
So sorry.
That completely that completely makes sense. Yeah. What it does mean is that we need to change how these guides are getting interpreted in order for this to work properly for the other side. Although there is another thing that I actually sort of mean to try that may actually work in this context, and I wanna see what happens if I do it. I'm thinking that it's not going to, but I actually want to give something a try. I probably shouldn't be doing this on a stream, you know, but here we are. I want to see what happens if I do this. I'm curious what happens if I actually leave them as positive x and simply shift them all over to the other side. Because bones are also allowed to have negative lengths. I grabbed the wrong thing. And this may actually be a slightly simpler way of doing this. Right. I see why this won't work. Or rather, I see why this will need additional work. Right? Because what we have here is something that you know, should probably basically do what it should do. Sorry, that was a bad way of describing this. Should basically do what it should do.
I don't know. I thought it was funny. So,
but notice that pop, that weird thing that was happening there. So that actually has to do with how the guides relate to each other. And let's again, you know, I want to do a little experiment here. See if I can figure out the right way for this to see if this is also a viable option, which it may well be. And if it is, it simplifies things a little bit. So maybe it's worth looking at. But take a look at these rotation values of the guide. So see how that thing was just sort of like the moment I moved it, it kind of like popped around. So this guide in a more or less not too far away from like being, you know, just on the x-axis basically, should definitely not have a value of negative 150. Like, definitely that means that one of these aims, and as you may recall from an earlier session, you know, we did the whole thing where we created a bunch of aim constraints to keep these guides together, as it were. The aim definitely should not be doing that. So let's just quickly fix that. And the way that we need to quickly fix that is change the aim vector. Did I get all of them? Yeah, I got enough of them for this to make sense, right? So we're still getting now we should no longer see quite such strange behavior. Now, obviously, they don't match up, but they don't match up because I gave these rotation values, right? You know, so if I had not given them rotation values, if I put this back to 0, then indeed, this should all match up pretty nicely. All right. This would actually make things a little bit simpler, and, you know, maybe I should have done this the first time I did this process. But before I can say, this is a valid way of doing this that saves us a little bit of time, because here's what's going on here, right? Our bone axis is pointing down positive x, but its length is negative. Now, are those two things actually equivalent? They may not be. And let me see about figuring out if they are. And the reason why they might not be, it has to do with the internals of how the spline behaves. Because a whole bunch of stuff we do in Contour has to do a bunch of calculations around twist. And if those calculations are assuming that the length is positive, which they might be, and Tagore, maybe you even know, I don't know if you remember, but if they are, we might get weird results, and we just have to go back to our earlier method of doing things.
Well, okay, but you're talking about bone lengths here, right?
I am talking about bone lengths, yes, but if they're negative, does
I believe that the spline should just sort of figure things out in world space and calculate its arc length, right?
Well, sure, the spline should, but I'm thinking specifically about twist, because it's looking at the transforms down the spline to do that. If those transforms are pointing in essentially the opposite direction, like the spline proceeds towards, you know, negative
so
x.
I don't think that it should matter, but don't quote me on this. I wrote this a long time ago, right? Yep. But I think that it should just all be like, I don't want to get into the details.
Right.
A little
well, it's the frames that I'm thinking of.
Frames, but sure.
There is an easy way for us to test. I'm going to throw a cylinder in here. I'm going to bind it. I'm going to see if it has any, you know, strange behaviors. If it doesn't, this might actually be a little bit of a simpler way of approaching this problem.
Yeah, I mean, the frame should just all be sort of relative to the spline, just regardless of its
regardless
configuration.
Of orientation. I
don't quote me too much on that. Like, it's been quite a while since we wrote this bit.
Well, like I said, we can just find out. Probably trying a new idea is actually not like the smartest thing to do on a stream, like in public. But apparently,
I don't know
what I'm doing.
It's unlikely to like crash things around.
Oh no, I don't think
I'll be very embarrassed.
You might get like weird results, and then I might discover it later and have to go back and fix
it. We've all learned something. Yep. We've all learned something then.
Well, it's just because the other thing is such a pain, and it just occurred to me, maybe this will work. So, let's see. Yeah, okay, this is kind of what I expected might happen.
That doesn't look good, does it?
No, and it's pretty clear to me, I think, why this is occurring.
Okay.
That is to say, or at least I think so, right? This is my theory. Which is that, as we progress down the spline, we have to do what is the term that we use I mean, the one that we all kept getting wrong, actually, the
Rotation minimizing
rotation minimizing frames. Thank you.
right? Which
And the
for some
rotation
reason in our code base is abbreviated MRF, or at least at one point was for a long time, because somehow we swapped some
That's
things. But
right.
they're
That's
rotation
right.
minimizing frames,
Rotation
which are a very
minimizing
nice
frames.
feature, very nice feature of Contour.
Oh yes, the rotation minimizing
have
frames are great,
them.
but I think they proceed in a particular direction.
I mean, they certainly do proceed in a direction. I was just a little unsure of the relationship between the transforms and the spline itself. And actually, it's a little funny, but I don't want to get into this right now.
Right. This is not important. The point is, I tried something, it didn't work.
Yeah,
I'm not actually that surprised. I kind of didn't entirely expect it to. That's
Okay.
fine. I'm just going to delete this and go back to what we were doing before. I'm just going to put all these back on the other side. And change their aims back again. Yeah, this will be fine. I mean, I probably will move. Oh right, I see. One of them is hidden under here. Which one is it? Is it joint one? It is joint one. There, just do this for the moment. All right, now they are all proceeding in the same direction, but they have the wrong direction of aim. Got to fix that.
What I will say about this, and this is kind of interesting because I've been thinking a little bit more, and I don't want to get into it very deeply because it is technical. I don't think it's actually a problem with rotation minimizing frames themselves, right? The rotation minimizing frames are really independent of anything having to do with that stuff. What it is, though, is that we don't just use rotation minimizing frames. We use rotation minimizing frames along the spline, which is just basically some differential geometry related to the actual spline. But we adjust it, like the standard way of doing rotation minimizing frames, which is a technique that certainly predates Contour. It's in the literature, right? Is just based on the differential geometry of the spline itself. But we do something more, which is that we make it also match the values at the joints, right? And it's that matching, I think, that actually does wind up being dependent on this stuff, not the actual underlying rotation minimizing frames too. What we're doing is kind of a hybrid of rotation and minimizing frames, but also adjusting them so that they actually take on the values at every joint of the joint itself. And so there's a little bit of like fixing things up. And this is actually a technique that I mean, somebody else may have done something like this at some point. I don't really know. But as far as I know, we pretty much invented this.
Yeah. Yeah, I mean, I'm pretty sure that people have done similar things, but I don't know that anyone has done it in exactly the way that we're doing it. Like, they've done things with similar sorts of results under different conditions. I mean, certainly, for instance, I would say, and I don't know, I think it is probably mathematically fairly similar, but in its results, but I don't know how they did it. Like, the thing that Sony demoed at SIGGRAPH with their rope system, like, does something, very, very similar.
Yeah, although I think Contour probably predates that by a decade.
Oh, yes, Contour predates that by quite a bit. But I'm just saying, like, other people have come up with stuff that kind of does a similar thing. It just, they may do it differently. But
it's a pretty obvious thing to want, I think.
Yeah. So anyway, now we're back to normal, and now we have to do a whole bunch of work to, my clever idea turned out to be not that clever, and we're gonna have to do it, the old-fashioned way. So I've switched to right. Which, interestingly, did I, undo this stuff or something? No, this should, Perhaps I did. Oh, yes, of course. I would have, because we would not have wanted that to be the case. Well, no. One second. This is the horrors of doing stuff live on a stream. Does this no longer actually output that stuff that I just set up? Because it kind of seems like it doesn't. Where's that conditional? Conditional's totally gone. Did I delete it? Did I have to do that again? Should have saved an alternative version or something. Whatever, it doesn't really matter that much. Yeah, apparently I do, because you can see that the condition's nowhere to be seen. I must have killed it when I was testing this out. But it will not take much to recreate. Especially because, and here again, like writing little scripts to do stuff, quite nice. Because now I can just do this. In fact, I could have turned this into a loop if I wanted to and made it even easier. But there's only like 2 more of them, so I'm not going to bother. Alright. So. Now we do have stuff attached to bone axis. Again, we're back where we started. Left is good. Right flips things around. As well it should. That is the correct thing for it to be doing. But now we got to go fix all the other issues with it. So first of all, there is the problem of the actual output of these guides needs to be flipped over to the other side, right? That is to say, they now need to be, they're doing the correct thing in terms of the bone, but they're not doing the correct thing in terms of anything else, right? Because what the bone is doing is the bone is saying, oh, the bone's length has now been inverted, right? But the way in which we are passing that length, in which we are passing that information into the bone, has not been, right? So the distance between these things is always, you know, it doesn't really matter what order that is in. Distance is sort of a very simple natural value that only goes in one direction, right? You can't really have a negative distance. That doesn't really make sense conceptually. But you can have the actual transform values of these being in a completely different place, right? So we need to make these actually match up. And let me just take a look at this for a second. I probably should have done more preparation and reminded myself how this works, because it's been a little while since I set this up in my previous componentized system. But essentially what's happening here, underneath, which we can see when we take a look at, you know, if we take out the, if we take our joint 2 guide, right, it's going into our inputs, and all of this stuff is happening with the matrix being inverted and a mult matrix. So what the mult matrix is doing is that it is taking in the matrices, you know, the inverted matrix of the joint prior to this one, and multiplying the matrix coming out of the actual guide by it, and that's how you sort of get the progression here. Because what we're doing is we're taking world matrices and we are fitting them into something that is actually hierarchical. So we always need to undo the world, put it into a local space in order to get values here. Part of the problem that we have here is that we are putting it into a local space that no longer makes sense because we've inverted the direction of these things. Does that make sense to, I'm never sure, right? You know, sometimes this stuff can be a bit complex. Please feel free to you know, like call out if like I am saying stuff that sounds like complete nonsense, right?
It reminds me a little bit. There's a guy named Jim Blinn who's very famous.
Oh yes, I certainly know of Jim Blinn.
You know Jim Blinn.
I mean, I don't know him personally, but yes.
No, but you know who he is. Anyway, I remember he said something that resonates with me about graphics programming, which is that the key in graphics programming is to have an even number of sign errors.
Ha ha ha! Yes. That is very apt. That also very much sounds like James Blinn. So, keeping in mind that these are all world matrices, right? Part of the problem is that the matrices are pointing in the wrong direction. We've got, you know, positive, this is positive x. I mean, here, now you can see it. It's positive x, right? Positive x, positive x. They're pointing at each other. But this is inverted. So what we need, one of the first things we need to do is to flip them around. And before I set this up to happen automatically when we flip that switch, I'm just going to do it manually. I'm just going to invert them, invert their scales, and I'm going to ignore the overshoot for the moment. Oh, did I? Yeah, I did. I did. I went ahead and hid the scale on a bunch of these things, and that is actually not a particularly useful thing to do, and I'm going to bring it back. Ah, yes, that is incorrect. Here's why what I just did is not actually going to work, right? It has to do with the order that translation, rotation, and scale get applied. Although, actually, no, we're getting the world matrices out of them, and we're using that to compute them. Maybe this will work. Let me just see for a second what happens. I mean, we're still
This is
getting
the
this
bit that
inverted, but yeah.
kind of reminds me of that. My general approach to getting the order of matrix multiplication right is to try it.
Yeah, well, that's basically what we're doing, right?
Every once in a while, you have to sit down and actually think through it, but like 95% of the time, I'm just like, well, let's try a couple orders, see what works.
Yep, exactly. What I had been thinking would happen when I did this, but didn't, right, is, well, we have a situation. I think I maybe see what's going on. Okay, I see what's going on here, right? So take a look at what happened here. What I just did, this is exactly the kind of thing that you deal with all the time when you're dealing with matrices, right? What I just did was I inverted it along scale x, under the assumption that now, I mean, it's not apparent right here, probably because I have this in world. Okay, here we go. Right, you can now see that the x-axis is actually pointing backwards. But here's the problem. When we are getting our length value there, we're not actually taking the actual distance between those two things. Maybe we should be. Maybe I want to go back and change that. What we are actually doing is getting this, joints, or actually in this case, this joints, right? So it's like this. We're saying how far away is this on X? And if you were to compare these, if you were to imagine these two in a hierarchy, which they are not, but we're doing the same math under the hood as if they were, right? This one is out now along a negative X direction. So what we have done here, watch this. If I were to to use my inputs to flip this back to the left side, it now returns to the original orientation, but now the length is negative, even though it is on the left side of the body. Because now that value is negative. What we actually need is for that value to be positive, because actually the length is really about the distance between those things. It is not actually about how far away it is on any particular axis. So let me just flip that back for a second, and then I will go fix that. Let's see. So let's take all these joints. We're just going to get a big mess here, but that's okay. What we actually want to do is to deal with their decomposed matrix nodes, right? And here's what's going on here, right? They're getting the world matrices, and then they are taking the output rotation, as they should. They're also taking the translation. The translation's going into X. The translation is currently negative. But we're, in a sense, double negativing it, right? The length is negative, but also the bone axis is negative. So actually, in this case, it ends up being ultimately positive, which is not what we want when it's on the right side, right? So here's a quick way of handling that. I don't believe that there is an absolute value node in Maya, but there is a distance between, which is effectively the same thing. And that gets plugged into, no, not next door, of course, the x-axis specifically, because it is worth noting that what we are doing here is specifically makes an assumption about the internals of this rig. And the assumption that I'm making, and I'm doing this deliberately because making something that can be flexible about axes becomes a lot more complicated, is that I'm making the assumption that these particular rigs always point down X, or negative X, right? But they've got a specific axis that they point down. And I'm making that assumption essentially because it makes things simpler, and because I'm making a system that is designed to build a particular sort of rig, right? Now, the rules of the system, right, this idea of explicit inputs and outputs don't make that assumption, right? I don't actually care. And in fact, within the way that the system itself behaves, there isn't really any assumption of directionality. So the componentized system itself truly does not care what direction you're pointing down, right? It's utterly irrelevant. However, the specific rigs that I'm making do kind of have to make a choice. You could make components that do something totally different, right? You could make components that point down Y or whatever you want. But you've got to, unless you want to make things quite a bit more complicated, choose one, right?
Right. You certainly could make things that could point down
sure
other axes, but it would,
if you wanted the same rig to encompass all of those things, it adds some complexity, and I don't want to, right? So I'm making the choice. these rigs are all pointing down the x-axis, and that's how they work, right? These components are, right? Not the componentized system itself, which doesn't care. And of course, within that system, if you ever really needed to, you could make something that did something different. It wouldn't really hurt anything. So here's our sort of like, silly absolute value thing here. And what that is getting us, you can already see it's doing this thing where like now, so look at this. So remember how we were seeing this thing where like we're moving this thing around, and it is we have these things inverted. We'll see what it's actually doing there, right? This line is actually the same as here, only inverted. It's in the opposite direction. And this line is the same as here to here, only it's actually correct. Like that's if it was the opposite direction, it would be pointing off in this way. Now here is where there's actually two things I'm going to do here. One is I'm going to very, very briefly rant, because I can't stop myself, and sometimes people seem to like it, right? About naming of internal nodes. Because one of the things that somebody out here is probably doing is that they're looking at what I'm doing here, and they're being like, you named this distance between one? How could you, right? And there is kind of a point to naming things, not distance between one. In this particular case, I actually assert that it doesn't matter. And the reason why I assert that is because if we think about the way that, from a programming perspective, say, and rigs are programs, right? What we have here is actually equivalent to, conceptually, a function. It is not equivalent to a particular instance of something like an object. Because it takes in data, it does something to it, and it outputs the data. There's no need, like calling this some particular name doesn't really help us identify what it is. We have to see what it does to see what it is, in a sense, right? All it does is sort of like gum up the works of, probably your code that creates things by making it have to decide on names that make some sort of sense, but which no one is probably ever going to look at. Because if I want to know what this distance between is doing, I can really only understand its purpose by looking at how, what are its inputs and outputs, right? Which I will have to look at, either in the graph, or I could query it or something, right? This is very different from something like contour bone 3, which is a specific contour bone that is like, analogous to like, this is a particular instance of something. And actually, and in that case, I absolutely do need to change this, right? Like I haven't yet, because I haven't bothered to, but this can't actually be named contour bone 3, right? It has to be named something more descriptive than that.
I think the analogy breaks down a little bit to programming, though, because in programming, for instance, you have this as distance between one, but if you did it in a different place, it would have to be distance between two or something, because in some sense, it really is an instance that exists, and it has to have a different name.
Oh, yes. No, I mean, I'm saying conceptually. Like, if I'm
right.
thinking about how I, as the rigger, am going to think about the rig, right? Obviously, Maya needs DG nodes to all have different names, right? So that's
but if it were a program, you'd be calling abs, not distance between, and it would be the same abs.
Right, exactly.
So to play, devil's advocate here, I'm just going to ask you this question, right? Like, the thing about it is let's say you wanted to be able to get all of the distance between nodes that were being used for the particular purpose that you're using them here, and you wanted to actually find them as instances in the scene. It'd be a lot easier if they had a common name, right? Because that's how you search for stuff.
Well, here's my argument about that. If I wanted to do that, and I wanted to do it in a particular, like I wanted to be able to do that consistently, first of all, what I would probably do is I probably would not actually use the name for it, right? The most likely scenario is that I actually go, all the things that are outputting into the length of a contour bone, or something like that, right?
Okay, fair enough.
Also, if I did want to have some data to be able to recall this very specific sort of thing, I think I'd rather do it with a tag. Because, we don't trust Maya names anyway, right?
Sure, fair enough.
So it's sort of like
attribute, basically. A custom attribute with like some tag value.
Right, or make a set of all the things that are that.
Make a set.
Right? Like if you explicitly want to be able to refer to them, I think there's better ways to do it. And that's just sort of my rant. Like, and people disagree with this, and they probably have good reasons to, right? Maybe somebody really needs that as an organizational thing. I'm not going to say that there's no circumstances where it would ever be a good idea. But my feeling about it is that something where conceptually, for me as the rigger, yes, this is distance between one, but fundamentally, it is distance between. right? Abs. Fundamentally, in this context, it's abs. I'm just calling abs, right?
Well, that makes sense to me because it says what it does on the tin, just as a
Right.
function should. It says,
Right.
okay, I do this. I am a distance between it. If you gave it some other name, it would be like a lot harder to figure out what it did just for
Right, right. All I want to know is this is a distance between. It's getting the output translate and it's outputting into length, and that tells me what it is, right? Like, and that is all I actually need to know. And if I give it some more complex structure of name, in all likelihood, in my experience, and again, you know, like I'm not there might be other cases, right? But in my experience, you're like the chances that you ever are able to get anything useful out of whatever name, probably pretty complex naming scheme you end up coming up with, are pretty low. Like, generally speaking, it doesn't end up being that useful, you know? And again, this is a very different thing for, like, DAC nodes, right? Things that are actually going to appear in the outliner that the user might interact with, or just that are clear instances of a particular thing. Like, not all contour joints are the same because they might have different data, right? They're not just like, well, I'm just essentially calling abs, right? This is not really the same thing. And that's a different case, and you should absolutely give all those things descriptive names, right?
Well, you know me and my Perlicisms, right?
Right.
I don't want to derail things too much, but I'll break out one of my favorite Perlicisms here. With regard to using the name to encode information, as you were saying, tags might be better. And I think he's sort of agreeing with you here, where he said, the string is a Stark data structure, and everywhere it is passed, there is much duplication of process. It is a perfect vehicle for hiding information.
So. Yeah. Well, and of course, this is why, even if you could trust Maya to keep names the same, which you can't, it would be always fraught with, you know, it's like, what's the specific naming scheme, right? It's always fraught with complication, right? And so I usually, for DG nodes, I like to just be like, you know what, I don't even care, right? So anyway, that was a rant and probably not very relevant. But here is the other thing I am going to say. I am going to write a little bit of code to do this again and again because this kind of thing really, really bugs me to do manually. And, you know, is this the best thing that I could possibly have done? Maybe not. I know that people sometimes find that confusing, but I feel like if I've demonstrated like what it does beforehand, like what exactly it is I'm doing here, then it's not perhaps the worst thing ever.
I mean, I actually think as long as you narrate, it might not be a bad idea. There really is some stuff in Maya that's just so much easier to do through the script editor.
It really is.
And I feel like even if you're not going to learn to be like the kind of programmer who writes big systems, it's really, really worth learning sort of how to write some one-liners that do these kinds of things. It is.
They're incredibly, incredibly useful, actually. And so, you know, yeah, maybe this isn't a bad thing. Maybe this is actually a good time for me to do that. You know, just a little bit, right? I'm not going to rely on it all that heavily. Until we get to the space switching, and then I will, because it will just take 10,000 years if I don't, right? You know. But here's what we can do. We can say, well, we just did contour bone 3. Here's contour bone 2. So get the selection, because we just selected it. Get the first item in the selection. Right, we're slicing. That's a Python feature that lets you get particular parts of a list, or any other sort of collection of things that is in a particular order. We're going to get.
I mean, I'd really call that just indexing, right? If you have one thing.
Yeah, no, you're right. I'm actually indexing. It's not really slicing.
Yeah.
Like, even though Python does let you slice, that's not really what I'm doing here. Now we've gotten into the weeds. Anyway, the point is, I just got the first item in the selection list. That was the important bit. I happen to know that it's contour bone 2. I'm getting the length attribute, right? That's what this is. And the length attribute in PyMel, I mean, this isn't how you would do it if you're using commands or OM2, has a method called inputs, which you can call on the length attribute. And that gives me the thing that is currently its input. And in fact, if I want to know exactly what it's getting as an input, I could do plugs equals true. And that will tell me what exact output I'm actually getting, right? And that's actually often a useful thing to do if you want to like insert something in the middle. So I'm going to go make a distance between node. Create node is the function you do that with. And I'm going to call it something like dist, I don't know, whatever. Made a distance between. But now I have it stuck in a variable, so I can do stuff with it. I can say that I am going to plug, you know, the thing that was originally the length output. Oh right, this won't work because the selection will change. Sorry. This is a weird thing. Like, anytime you create something, it automatically changes the selection. So if you're relying on the selection later in the script, it's going to be all messed up. So here's what I'm going to say. I'm going to say bone equals pa.selected, first item in the selection list, and then this becomes bone length, dot length, dot inputs, right? So I'm going to put that into, here, let me just get rid of this for the moment because I'm about to create a new one. Dist, what do we need? It's got to be 0.1x. Is that how you do it? I'm pretty sure it is. And then dist dot 0.1x goes into bone dot length. So very simple little thing, but it means I don't really need to be like, oh, what was going in there? The script just finds out, right? Assuming it worked, which of course it did not, because I did a silly thing, right? That's on line 5. Yes, because inputs potentially have multiple inputs, so it returns you a list. And the list, of course, cannot be connected to anything. I need to get the item actually in the list. There's only one of them. Right, because also that's actually the output that I've got to plug in there. Distance specifically. Of course, this is the other thing about writing scripts. They're always broken, right? But you know, once you get them right, which usually isn't that hard, when there are little things like this, they become super. Yeah, there we go. And that just means I can just do it like and just be like, oh, I'm going to do it for this one, and I'm going to do it for this one. All right. So now this is sort of like an absolute value, right? You know, we're no longer going to double our negatives. So let's take a look at what this is doing. And indeed, this is doing something much more reasonable now. I mean, it's still wrong, right? You know, probably because I missed one. Yes, because this contour joint socket 1 does not have a, you know, it's like, let's take a look at this bone length. See, right, so positive, positive, positive. Yeah, it's doing the right stuff. So how come this one's still pointing backwards? Give me a second to figure that out. Yeah, because that is also positive and pointing on the x-axis. I'm probably missing something. This is probably real dumb. I am thinking that this is actually related to the direction that this thing, because the bones all have, you know, a negative length, right? But the joint socket is purely getting the transformation of one of these locators being passed through the system, and therefore I probably need to invert it in some fashion in order to make this work properly. I'm just thinking about what that's going to need to be. Right, because this is pointing straight back from this, but this one is pointing forwards, right? Although I really do wonder what happens if I move this over here. Yeah, okay, that's what happens. Yeah, it's doing and it is doing appropriately weird stuff. Probably because I did not do this thing. Oh no, I did do negative x scale. I'm sorry. I am talking to myself while I try to solve issues, as one does. It is always embarrassing when this happens and you're actually on a stream, but this is all perfectly normal. I swear. Yeah, I still have some negative scales. Let me fix that. That's more like what I expected to see. Now, if I now change these so they do have negative scales, there we go. I just had a mismatch in negative scales there. Right, because again, you know, if you want these things to point, to be in the opposite direction and get an appropriate value, you actually need the scales to be negative, right? So let's now say that these are over on the other side. And I think we are pretty close to having this thing actually be reversible and actually be correct and not be sort of like flipping around in weird ways. Let's see if I'm right about that. I am not. Oh, that's right. And I also need to make the aim axis negative, or we're gonna get real weird results. So now it's time to actually hook that stuff up, right? Because previously I was just sort of manually doing that because as for test purposes, but all of that also needs to respond to the inputs. And like I was saying, and I was sort of in the middle of that as I started talking over myself while I was thinking about this, yeah, this is what rigging is like, right? Like, you know, it's a little embarrassing to be doing it on stream, but this is perfectly normal. You're always a little confused. So, yeah, these are pointing along down positive X right now because of the aim, which is why they have such wacky rotation values, which is definitely not what we want. And now I can basically affect both the scale and the direction of the aim constraint of each one of these things, which should successfully, like, make this work. Actually, I have a different idea of what to do with the scale. I am going to flip all of these back to not having a negative scale. Which, of course, you know, screws them up in that respect, but that's fine for the moment. These, however, we definitely need their aim vector to switch over to -1 on the x-axis when it's in the right-hand state. So we just make another conditional for that. And yeah, let me just start by doing this. Plug side into first term as we did before. If the value is 0, i.e. it's along the positive next axis, then the color history is going to be 1 and otherwise -1. And then we need to drop all these in here. And here, once again, like now I'm going to do another little bit of scriptiness. I don't really have to. I could hook these all up by hand. It wouldn't be at all unreasonable to do, but I hate it, so I'm not going to. I would rather occasionally have something go wrong and have to fix it than just do stuff where I am constantly doing repetitive actions. It is a bit of a quirk. I'm just going to call this condition equals. And then for n in pa.selected, instead of getting the first item in the selection list, I'm now looping through everything in the selection list. I'm going to say condition dot, what is it? It's output R, isn't it? Yeah, it is. Pretty sure. Let me just take a look. Oh no, of course it isn't. It's out color. We can never be consistent about anything ever. And it needs to go into aim vector. Yes. Specifically aim vector X, I think is probably what that's called. Let's see if, yeah, there we go. See, that's always quite nice when it actually works the first time, which it hardly ever does. And as you can see, this is all now working correctly. Did I give these the negative scale? I did not. And without the negative scale, it will probably do something a little weird. Actually, no, it didn't. That seemed to work even without it. It may be that the real thing I needed to do was actually the aim vectors, and the negative scale didn't actually matter. That does seem to potentially be the case. But let's just see. Yeah, because we're getting perfectly reasonable values here. Yeah, that is the case. That's right. The negative scale isn't actually important at all. So here's basically how this works, right? We now have a reversible, or a fairly simple reversible rig. But it's easy enough to get it sort of mismatched, right? So if we set this to be on the left side, everything's going to continue to match up, but our values are going to end up being kind of weird, right? You know, we're going to get, you know, this will all work fine. This is not positive x-axis, but we're likely to get somewhat weird results. Note how this is sort of like canted at a weird angle. It's because, you know, look at this negative 140, right? You know, that's not a good base number for our base state. And that all just comes down to, well, we do actually have to, when we are doing things on the left side, put the nodes on the actual left side in, you know, left direction order, right? So nothing about this is going to enforce that. it's all going to be like, here, let's just do it from this side. Let's make it easier. It's all going to be a matter of you use the one that makes sense, right? And I think that's okay in this context, because we're talking here, in the case of a finger or an arm, about something where if you're using it on the left side, and we're creating this body plan, right? Our intention here is a user using the body plan can they're gonna come in with a body plan with a left and right arm. They're gonna already be set up correctly, and left and right fingers, right? They're already gonna be set up correctly, and therefore we're not really expecting our user to actually necessarily mess around with this. Now, of course, they can if they want to, right? But if you are, you're taking on the responsibility of understanding that the left switch there is only appropriate for things on the left-hand side. And if you're not, that's perfectly fine. You're just sort of moving these things around. We've given you a set of fingers where this is all correct. And so I think that's, that isn't how I set things up when I did the componentized system that I did for TF2. What do I say? TF2, man. For TTF. But again, it's sort of like slightly different cases, right? In that case, I had it inferred, where I would look. I had a system that looked at the position of these things and said, oh well, this must be a left finger, right? And then you could literally just move them over to the other side, and everything would still work properly. It was a bit more complex though. And in this case, I don't really feel like it's necessary, and arguably it wasn't then either, right? It's sort of like sometimes you realize that something that was a bit more complex that you did wasn't actually worth the complexity. Like you didn't really gain much by it. So, and I would say that this was one of those cases. But now we have a working reversible finger. Now, what I had originally intended to do on this stream was to then go on to either do the reverse. Which that was incorrect. I meant to do this. Either do the reversibility for the arm, or move on to doing space switching. However, it's now already 6 o'clock. We could take a look at the space switching a little bit because but I don't really want to go too much past an hour and a half with the streams these days. So I may not actually fully do the space switching feature. But we can take a look at what it means to have space switches or at least discuss what it means to have space switches in the context of a componentized rig. Of course, one of the base assumptions of the componentized rig is that rig components will always they can only talk to anything else in specific agreed upon ways, right? And that means that the normal way that you might set up a space switcher, which is like you have a little script that sets up some constraints basically to to do your space switching, right? And just sort of grabs what it needs in the scene to do so. One moment, let me just check on something real quick because I might need to. Yes, I need to respond to this. One moment. Okay, so sorry about that, but occasionally important questions are asked and must be answered, right? Where was I? I was saying right, it's only allowed to communicate with the rest of the rig in very specific predefined ways. And what you normally have is you have some script, your auto rig script probably, or maybe some script that you're just using to make them extemporaneously that is going to sort of drop a bunch of transforms into the scene or set up some constraints or both, right? Whatever it actually needs to do to set up the space switching, but then it's going to be locked in. And of course, the really nice thing about componentized rigging is that it's not locked in. We can, in fact, do space switching in this fully componentized way where we can continue to adjust the proportions of the character at any time and have the space switching completely continue to work normally. Which is really awesome, because this is exactly the kind of situation where if you've had to screw around with anything that an auto rigger created, tends to break down really badly, right? You had to sort of like, for whatever reason, right, you had to set up a space switcher that worked a little differently than whatever the auto rigger did. Now you can't go back, right? You can't change the proportions of anything. You don't know what's connected to what. Like, it's just a consistent, perennial issue, right? You never have that here. But what that means is we need to basically pass through a bunch of additional information about the spaces that are available to switch to. And then we have to make sure that the way we switch to them is by introducing either transforms or constraint offsets, depending on how we choose to implement our space switching, that can receive the right data from the guides, well, from the inputs, right? I mean, we actually don't care what where that data comes from ultimately. It happens to be from the guides. We care about what the inputs are, that in order to fully determine how the space switching functions and sort of, where everything needs to be and what it needs to be relative to, and what, in terms of offsets from those inputs, so that we don't end up in a position where, anything in any way gets baked into the component. Because, and I've sort of mentioned this before, I mean, probably a lot at this point, but I think it's maybe important to hit it a little strongly a lot, right? Because it is such a different concept than the way a lot of rigging works, right? The whole idea with componentized rigging is that the only things that can ever differ from multiple instances of this component, right? Like your right arm, your left arm, and then you've got your one character's right arm and a different character's right arm. Like, these are all, you could say, like, different instances of this component, right? Is that the only things that can ever differ are the inputs, which is what makes it possible to change the behavior at any time, or to change the configuration, the character's proportions, or potentially swap out a component at any time without actually disturbing the behavior of your rig at all. And so we have to maintain that, right? If we don't, we're losing the benefit. So let's take a look at the arm for a second. Let's take a look at, here we go. Here's our arm. Because here is a case in which we definitely need some space switching. We probably don't need it on the fingers. I mean, you conceivably could have to have space switching on a finger, I guess. That's not completely unreasonable. But we don't, that's not really a particularly normal thing to do. So we're going to take a look at, I see, I already did this on the arm. Like I said, it was sort of already there. Well, you know what? That's actually perfect. I'm going to walk through what's going on here. And then next time, we'll implement it, maybe for a head or something. I'll pre-make a head, so you don't have to watch me do it. You've already watched me make a simple case like a finger before, right? If head's not really that different. And then I will actually do the space switching for the head. But beforehand, what I'll do today is that I'll describe what's going on here in the hand, right? So as you may note here, we've got these things called character and upper body. And in fact, as I am already looking at this, I'm realizing I actually want to change the names of these things, right? Because this isn't a very good name. What this is upper body space, right? It's a lot, that makes it a lot clearer. Character space. World space, right? That's sort of that makes it a lot more clear what's actually going on here. And we have inputs that are going along with it. So note that we have upper body and upper body offset, which is very, very similar to anchor and anchor offset, right? Which we've already sort of seen how that works with parenting the rig, right? And this is going to behave very, very similarly. It works essentially along the same concept, which is we have a bunch of incoming world space matrices. That's the format in which we get sort of the data about the proportions of the rig. It's a bunch of world space matrices. Because they are in world space, one thing that is very convenient for us is to continue to treat them as something equivalent to world space. So when we have, this was I can't remember if it was last stream or the stream before, but we went ahead and implemented this for the fingers. The whole deal with the anchor is that by making that offset, right, you're like, oh, well, here's the position of whatever I'm parented to, right? In the case of the fingers, it's the hand. Here's the position of the hand. But we also have an offset that's like, here's the canonical position of the hand. Here's where the hand is in bind pose, which is different from wherever it may be in the scene right now. And it is the difference between those things that's actually going to move the fingers around. Which, and I believe I pointed this out at the time, is actually extremely analogous to the concept of a bind pose when you're doing linear blend skinning. Like, it's almost, I mean, it literally is the same thing, actually. It's just that you're moving, instead of moving vertices around, you're moving other transforms around, right? Same concept. Essentially, you have the difference between a bind state of things and a current state of things that the animator has set, by moving stuff around and creating keys and whatever else they're doing. And that offset, and arguably, should I have called this something other than offset? Maybe I should have called this like upper body bind position or bind transformation. That might have been more accurate. And perhaps I should, just to make things a little clearer, go back and change that, but I'm not going to do that right now. Just as we can do that for essentially parenting the whole system, for moving this anchor around, we can also do it for any of these individual spaces. What that means is that the space, because again, when we're doing this, we're saying, well, the upper body is in some location in the world, right, in its default pose. And what we're doing is we're inverting that matrix and saying that the upper body will therefore be back at 0, 0, 0. It's going to be back at identity. It's going to be the identity matrix in its default pose. And then wherever the user has moved it to will be that essentially transformed to be relative to the actual place the upper body characters move the upper body. Again, it could be difficult to find the right language. Like, I can visualize this very clearly. It was very difficult to find the right language for it. In fact, perhaps I should open Photoshop and draw little diagrams and stuff. But we kind of already talked about this, and I sort of showed it in a previous stream. So maybe we don't really need to do that right now. So we have this character, this upper body space, which right now is at 0, 0, 0 because it doesn't have anything being input into it. But where this would actually end up being, I mean, the upper body space would actually always be at 0, 0, 0 in bind pose, but then it would move around. And that's why we can say that things like the hand PV control simply get whatever input they are receiving. Now, in the case of the pull vector, this is maybe not the simplest case, because in the case of the pull vector, that's not controlled by any specific input. The pull vector is actually being calculated by looking at the inputs. I mean, essentially, it is the same math that one would use if one were writing a function that was like, okay, here's like these 3 points. Where do I put my pull vector? Right, and there's this is essentially a similar concept, right? It figures that out, but it does it in the graph so that as you reposition the guides, it will always choose the right position for the pull vector to be at. So that's not really quite so simple. There's something more complex going on. However, if we look at something else that has a space switch, like the hand, right? The hand is naturally, as it were, in character space. And character space, in this case, actually represents the idea that, like, your character's got, like, a base control, right? Base space might also work. I mean, there's various things you could choose to call it. But your character's got a base control. And a lot of the time, that's where you want your IK hand to actually be, right? You want it to be in base control space. You want it to not respond to the movement of any other part of the body. You want it to stick, right? Now, I actually kind of hate this whole thing, right? I have ranted on many occasions about the evils of space switching, but as long as we are not using something like the ephemeral system, which, obviates the need for space switching entirely, or either that or essentially has space switching on all the time and nothing, depending on how you look at it, essentially nothing has a canonical space in the first place, so no space switching is needed. You really, really have to have it, right? You can't really avoid the necessity for having some kind of space switching outside the context of something that actually doesn't require it, which would not be a conventional interpolating, character rig. So as long as we're going to have it, you're probably mostly going to want the hands in character space, which is probably why I stuck them in character space to begin with. I see why I did that. Now I'm recalling why I stuck them there. Because you might say, well, that's all very well, but since the hand IK buffer is being controlled, Like, so what's happening here with the space switch, for anyone who's unfamiliar with how space switches usually work in Maya, right? What's usually happening is that the buffer is getting constrained to other things. And that might be a parent constraint with an offset. In this case, because it makes it a little easier to do, I have specific transforms in the scene that are parented to these various spaces. And those transforms are it's actually blending between when it blends. Well, it actually doesn't blend, it switches, but when it chooses a different space, right? That's not a necessity. You can do a constraint a space switcher completely with constraint offset values, right? If you have a constraint with offsets that sort of encode that information, and you could do that in a componentized way too, honestly. Arguably, I actually shouldn't be doing this because it adds redundant nodes. And I don't generally love adding redundant transforms. I really dislike it. And one of the things that I find to be true in many rigs, right, certainly not universal, but it's often true, is that having a lot of redundant stuff ends up actually having bad performance implications. Not this. This is not going to matter, right? But especially when you have multiple full versions of the hierarchy, or like, a lot of sort of internal redundant stuff, it ends up having bad performance implications, or it can, right? It doesn't always, so it depends on the context, right? And it also makes it much harder to look at the rig and understand what's happening. And that's, I think, in many ways, the performance issues aren't quite as bad now that we have parallel eval, although multiple redundant hierarchies will still sometimes bottleneck parallel eval too. But it still just makes everything complicated in a way that I find really detrimental, right? In this case, I am introducing a little bit of redundancy, because we don't necessarily need these things to be transform nodes, right? They could just be data that's going into the constraint offset or is being used internally with DG nodes or something like that. I've chosen to do it in this case for clarity, right? In this case, I think that the clarity of doing it this way outweighs the sort of unfortunateness of having additional transforms in the scene. And your mileage may vary on that. I go back and forth about it. I'm not totally certain that this is the right way to do things, but it's how I've chosen to do them, and it's not the worst way to do it either, so I think I'll live with it, right? But here's the point I was going to make. Like, why have this IK buffer underneath the character space as an actual hierarchy thing? I mean, it could be right out here. Same thing, right? It wouldn't make any difference. Because in this case, for instance, if I were, and because they're all, like, they don't have any incoming data right now, like, they're all back at 0, 0, 0, nothing I do here is actually going to change anything. It's not going to move anything around. Well, the shoulder might, actually. Because one of these is relative to the shoulder. And as you can see, that will actually change things, right? Now, the shoulder doesn't need to get its own space, because the shoulder is actually part of the same component. And what's going on there, if we take a look at the clavicle control, is that I've got a hand IK control. This is essentially the space transform, and this is being figured out by basically figuring out, like, what is the transformation of this world space matrix in the joints incoming world space, the shoulders incoming world space matrix. This is one thing that's very nice, by the way, about having all of the data flowing through the system use world space matrices. It's that I can, because if I did it in a way where I was passing local matrices through, then the hand matrix would probably be in the space of the elbow matrix. And or be relative to it, right? The hand would be in shoulder space, which would mean that it would be much harder to ask, like, well, what's the hand the hand would be in elbow space. What's the hand in shoulder space? In this case, there's no difference between asking those two questions. I can ask what is anything in anything space anytime I want to. In the other case, I would have had to consider the elbow matrix too, keeping in mind that, unlike an actual transform node, because when I'm passing the matrices around through the graph, through those input attributes that I have in here, all of these input attributes are being passed. I mean, essentially they're being passed through to DG nodes, right? They don't have any place in the Maya hierarchy. They're just a matrix. And as a result, I can't be like, oh, but what is this in world space? Well, it doesn't know. It's just a matrix, right? So passing them through as world matrices just makes it much easier to figure out stuff like this. Makes it really trivial in a way that otherwise it just, adds more complexity. And we're always trying to figure out how to not add more complexity, right? So, changing this space is basically changing which one of these things it's pointing at. And we can tell each of these transforms where to be by simply taking the various transforms we were receiving in the inputs. And so in the case of the upper body and upper body offset, this is going to work very similar to the anchor, because the upper body is essentially more or less guaranteed. Like, it's the topmost thing in the character, right? Pretty much, right? Other than the actual character control itself. And the character control itself is pretty much always at 0, 0, 0. So upper body and upper body offset, acts basically like it's in world space, much like you don't really need to consider anything else. For the things where you do need to have another transform in there in some fashion, like the shoulder, that is often something that is actually internal to the component. So you already know what that is. Like, I already know the world space bind pose transformation of the shoulder, the elbow, the hand, etc., from which I can derive all of the information I need to basically figure out where to place these transforms. So arguably, maybe shouldn't have actual transforms there for that purpose, but either way, you essentially can derive all the information you need to create a space switch that will work regardless of the input bind pose that you're getting from the guides, by essentially making all of this information live. And that's one of these critical differences, right? We're not generating something in here that now is at some particular place. It's always relying on the inputs in order to know where to be at all times, which is part of what it means to say there's no actual difference between multiple instances of the component, right? Any instance of the component is identical with the exception of the inputs that it receives. And what it does in response to those inputs is always uniform, right? This is kind of what I was trying to get at in the first stream that we did, where I was, trying to figure out how to explain all this and kind of turning myself into knots. And I started like comparing it to functional programming. Because while they're not exactly the same thing, there is this idea of like, you have something that calculates a result, and it's not allowed to go reaching outside itself for any of the data it needs. You always know exactly what it gets, and you always know exactly what it can give. And it simplifies things radically when you can do that. Obviously not everything I'm doing here really, certainly this is not functional in the same way, right? But as actual functional programming is. But that concept has these really, really nice qualities.
I'm not really sure. I think the analogy is really, really fairly precise there, right?
Maybe it's
referential transparency. The function.
Yeah, it is basically referential transparency. Yeah.
If you know what its inputs are, you know what its output is.
Exactly. And it can never do anything other than that inside, right? It processes the inputs and gives you outputs, and that's all it does.
Right. And if you're really following the rules, it's also not going to leave any persistent change.
Right.
Its output is going to cause some side effects itself, but the stuff that's happening inside it is not going to cause any change that's persistent, or
that's right,
at least in a way that is visible from the outside of it.
Indeed. Right? And what that means in this case is that, there's actually a pretty clear difference here, right? Which is to say, the only thing that can change here are connections. Or I should say the connections themselves can't change. What I mean is data coming in on a connection to a node could be different. But the data that is simply set on a node, right? Like, the data that a particular attribute has never can be, right? Only data flowing through connections could be different. And of course, they usually will, right? Because you have different data coming in for the inputs. Therefore, different data will flow throughout the system, right? But only that flowing data can ever be different. Static data, as it were, right? Like just values that have been set in attributes are always the same for every arm. They're never different, and therefore the behavior is never different. There's actually one very notable exception to that, which we will get to at some point, which is actually the appearance of controls. That is to say, like stuff like how big are the circles, right? And you could turn those into inputs too, actually, and maybe that is actually what we should do here. But it does make things a little more complicated, and people do like the ability to like select one of these controls and like actually reshape it into something, right? And I did not want to make that impossible. So that is actually kind of an exception, but part of the reason why it's an exception is that it has no actual effect. It's purely cosmetic, right? It has no actual effect on the behavior of the system. It just changes what the control looks like. And so I sort of decided, that's okay, actually. We can kind of break the rules a little bit in that case. But anyway, we are just about at 6:30. So, and I think I have, sort of explained some of these concepts, reasonably, to some degree anyway, and we can go start, implementing them next time. So I think that, I think we're about in a good place to cut it off for today. Next time, we'll go ahead and do that. Maybe we'll get to, I'll probably for the head, since that's a simpler case than the arm. And maybe we'll get to starting in on the leg, which is much more complex than the ones we've done previously. It's complex, more complex than the arm, in fact. In fact, it is undoubtedly the most complex of the various components that we're authoring here. Although much less complex than it would be if we weren't using Contour. Because so much of the behavior the component would need is already sort of present in the IK handles and in the bones themselves, right? One of the things that you would have, and again, if you were doing this and you were doing it with conventional rigging, you might have subcomponents for a lot of this stuff, right? You need twist, right? You need to figure out, a stretchy IK or something. Like you need something that might be complex. And for a componentized system that needs that, yeah, you might well have subcomponents to handle all of those things. We don't really need to, because Contour already handles all of those things. Which makes this a heck of a lot easier. But anyway, we will talk about that stuff then. That is going to be next Tuesday at 5 o'clock. After that, let's see, how many Tuesdays do we have? Yes, so after that, we are probably going to end up taking a break, because it will be we'll probably do the 20th, but after that, I probably will not be available on the 27th. Probably no huge surprise there. Nobody's going to be terribly shocked. But we'll be picking it up after that and probably wrapping up our componentized rigging, because we're just about, once we've done the foot and we get it together and apply it to a character, which we are not super far away from being able to do, like we'll have made a system, right?
Okay. Is it just the 27th that you'll be missing?
Yeah, pretty sure it's just the 27th. I'm going to double check on the 20th.
Third, yeah, I think, right?
Sorry?
The third would be the next Tuesday,
yeah,
right?
The third would be the Tuesday after that.
Yeah. Okay.
Right. But at that point, and then maybe we'll move on to animating cloth, which is something I'm excited to move on to, but we're not there yet. So, I'm not going to make a big deal out of it. But
sometime we ought to squeeze in a stream just sort of about basic stuff in Python scripting, but maybe not. We probably should at some point. I mean, it's something that comes up for us a lot in the streams, right? Which is you want to do this, and it really is a very useful thing to be able to do basic stuff. And, as you know, I am actually going to start streaming some stuff about programming.
That's right.
I don't know. At some point when I have that a little more set up, maybe I'll be sort of unprofessional here and promote my stream on our stream.
I don't know if that's even considered to be unprofessional these days.
Not these days, right? Clout chasing's pretty much.
Clout chasing's a thing, and I don't even think it's looked down on all that much. Like
yeah.
Do you hear anybody ever being like, "Oh no, you sold out"? Like that's not a thing
anymore. No, go right ahead, sell out. Yeah. All right. Well, thank you very much, Raph. I mean, that was pretty illuminating again in a lot of ways. This stuff's pretty interesting. As you know, I'm not a rigger, so I'm sitting here watching and understanding some of it and not understanding some of the rest of it. But
that may be the case, but it is worth noting here, like so much of what I came to understand, right, about how to rig effectively and quickly and get a lot of stuff done basically came from the programming lessons that I got by working with you on stuff. Because so much, like, you can, and it's very clear. I mean, we sort of discussed this a little bit before, and, we do want to cut things off, but I'll just mention this, right? Like, how some of this idea of having things in chunks like this does date back to the setup machine, right? But I didn't understand how to make things go together, right? I didn't understand that it was important to have clearly defined inputs. I didn't understand that you could sort of make components fit together and think about the data flowing through them in a way that drastically reduced their complexity, right?
Yeah. And of course, a lot of that,
things, right?
A lot of that does come to some degree from Raphael Frangipani, right? if
Oh,
I'm
it
saying
definitely
his
some
name
of it
right.
does,
I hope
right? But
so.
I wouldn't have understood what he was
But your
getting at,
understanding of it
right?
certainly is helped by having programmed some. That makes a lot of sense.
Yeah. Like I wouldn't have gotten the concepts, right? I wouldn't have gotten
Yeah.
why that was important. I would have been like, well, I guess this seems to work, but
Yeah.
like, this other thing does too, right? I don't really see why it's important. I wouldn't have
Well,
understood,
and he is
right?
indeed an
Oh
accomplished
yes,
programmer.
very much
So
so.
that probably led to a lot of his insights into this as well. So
Indeed.
yeah.
Like he is very much like a very experienced graphics programmer,
Yep.
and someone who's done a lot of work architecturally.
Well,
Like,
and interestingly, actually, somebody who's done quite a bit of actual of sort of what we call pure functional programming. I know that he's
oh
used
yes,
Haskell a reasonable amount, so he has some of these ideas here. And I think that that's not necessarily true of all graphics programmers. A lot of graphics programmers come out of a very, very like procedural imperative
yep, very
way of
very much
looking
so.
at
No, I
things.
mean like that was
Yeah,
absolutely like the ways that he like it would be very surprising to me if he hadn't been highly influenced by functional programming concepts coming up with a lot of the componentized rigging approach, right? Nevertheless, I wouldn't have understood why it was important, right, if I hadn't gotten that sort of background of having worked on stuff with you where I started to see like you remember when we were working on TSMG, right? And I put together this idea of how the system should work, and remember how painful it was to like turn that into code, like the
I
tail
do.
I'm
I
thinking of
do
in
recall
particular.
the tail in
The
particular.
tail.
Yeah,
The tail was
this
like a
stuff
mess.
would have.
And the thing is, it's because I didn't know how to break things up mentally. I didn't know how to create. I didn't know where the borders of things were. You know.
Right. Right. We could have, I mean, we actually could have used sort of componentized stuff for the segments of the tail and
We
simply just
absolutely could have if I'd understood that, right?
right.
Like,
But the thing about what we actually had to do was generate all of the rigging in code, and that was not the easiest thing in the world because, of course, that tail rigging was extremely complex. I
right.
remember
It was
Brian
quite
and I
complex, and
having to really
it
understand it.
didn't
Yeah.
actually have to be. Right? Like I now understand, right? That it could have been a lot simpler than it was, and it could have been turned into stackable components. And
Right.
that honestly would have been like it's amazing what the difference is, right? That could easily
Yeah.
have reduced the amount of work necessary by an order of magnitude, like easily.
Well, in addition to like my love for parallelisms, I also like to quote Alan Kay a lot. And one of the things he talks a lot about is just the pop culture of programming, right?
Mhm.
Which is that we tend to forget a lot of things that people have already known in programming. We tend to keep reinventing things and sometimes reinventing them a lot
Right.
worse than when they were originally invented. And of course, there is the same thing where rigging is a kind of programming, and yet a lot of the systems for rigging that are out there really don't make use as much as they could of a lot of the lessons that programmers have been building up now for a long time.
This
Right?
is so true.
So,
Like it's the sort of thing that just like and this is something I've ranted about on many occasions, but it's exactly that, right? Like there's a whole massive history of software development and technique, right? So I mean, which of course, like also people argue about it all the time and people don't agree about it, and like it's not like it's like, oh, here's like everyone knows exactly how to make software, like but
well,
there
and there's a lot of
nevertheless
lost
is
knowledge, as I
enormously
said.
valuable lessons in there, right?
Right. It's just like this pop culture thing. It drives me crazy even within the context of programming, which is there's stuff that, like, for instance, comes from Common Lisp, which was defined sort of in the 80s. And there are a lot of modern languages that would be so much better if they had, like, people figured out how to do this and what the right, or at least a very good design for this was at a certain point. And you constantly see in more recent languages like quite poor choices around this when people kind of worked this stuff out quite a while ago. But we just keep reinventing things. It is
Right.
sort of the nature. It's the nature of the beast.
Yep. Well,
Okay,
anyway,
so
yeah, it's about time
we're
for us to be
ranting.
done. But
We should be
we'll
done.
hope to see you here again at 5 o'clock. 5 o'clock EST. I should mention that part. Next Tuesday. And probably the 20th, probably not the 27th, but and we'll continue with this, and hopefully we'll get back into some ephemeral animation pretty soon. I think. Pretty excited to show some of the new stuff. But again, I'm jumping the gun a little bit here. Anyway, see you guys, and please tell all your friends to be here, and like and subscribe. That's right.
Yes, like and subscribe, and hit the little bell if there's a little bell.
Yeah. That part's important.
Yeah. All right. Thank you very much. Have a good evening.